Perseverance is paving the way for human exploration on Mars.
10, 15, 20 years from now, all of your friends are going to be like, oh, you haven't been to Mars? You have to go.
And our centuries-long obsession with the red planet.
I claim this planet in the name of Mars.
From Marvin to Matt.
In your face, Neil Armstrong.
Finally, it's the long-awaited landing of the Perseverance.
I really do believe it's a historical moment, not just for our team, but as human race.
ABC News Live presents Mission to Mars. Live. Here now, Eva Pilgrim and Will Reeve.
And what an exciting day it's going to be here in our studio at NASA and on Mars, as Perseverance is just minutes away from entering Mars's atmosphere.
In just a few moments, we will go to ABC's Gio Benitez. He is at the Jet Propulsion Laboratory in Pasadena, California. That's where the scientists and engineers behind this mission are locked in and hunkered down for the big landing.
And this landing is not expected to be without drama. In a moment, we're going to tell you about the so-called 7 minutes of terror. That is a nail-biting period of time from when Perseverance enters the Martian atmosphere at nearly 13,000 miles per hour to when it has to land safely at 0 miles per hour.
We are thrilled and quite lucky to have some experts here with us in studio to help us navigate this mission. Both of them are experts on space. One of them has even been there herself. Former NASA astronaut Dr. Katie Coleman, veteran of 2 space shuttle missions and over 150 days in space, and astrophysicist Professor Dr. Hakeem Oluseyi. Welcome, Katie and Hakeem. Thank you so much for being with us. It's going to be a huge help getting us through all this.
And so much excitement at the Jet Propulsion Lab in Pasadena right now, and that is where our Gio Benitez joins us from. Gio, let's set the stage for everyone.
Oh, gosh, everyone is just so excited. Will, Eva, good morning, good afternoon. Look at that. We have all sorts of times here. But this right here, this is the full-scale model of the Mars rover Perseverance, or Percy, as so many people call it here. And it is just moments away from entering Mars atmosphere. That Mars atmosphere, they're a very dangerous situation. A lot of people are going to be watching that, no doubt about it. What we are going to watch here together right now is history in the making.
Are we alone? Are we the only ones?
I think we're just fundamentally curious about our place in the cosmos.
We've been thinking about the possibility of life on other planets for hundreds of years now. And this is our first opportunity to perhaps find it.
Engine ignition, 2, 1, and liftoff.
That is the incredible mission of Mars 2020, to determine if life exists or has ever existed on another planet.
3.5 billion years ago, when life was just getting a toehold here on Earth, Mars was wet and warm and very similar environment to that which Earth has. So there's a possibility that early Mars was habitable for life, and that life could have also started on the red planet.
To answer that question, NASA scientists have created the most advanced robot ever sent into space.
Perseverance has within it the most complex, sophisticated robotic system we've ever sent outside of Earth.
We're landing the heaviest payload that we've ever landed. Perseverance rover is roughly the size of a car. It's about 10 feet long.
She is the biggest rover, the heaviest rover. She has got packed with firsts from the bottom to the top.
It's part of a mission that has been more than 8 years in the making, with a price tag of $2.7 billion. Its destination, an ancient dried-up lake called Jezero, 3.5 billion years old.
Based on everything we know about that environment, it was habitable. Life should have been there. So I think we are very optimistic, I'm very optimistic, that we will find signs of ancient life there if they ever existed on Mars. There's no reason why they shouldn't be there.
Don't expect them to find creatures like we've seen in movies like Mars Attacks.
Martians. Funny looking little critters, ain't they?
What they hope is to find something much simpler, ancient evidence of tiny microbe-sized life. But none of this will happen until the rover is safely on the planet.
Space is hard. When I started this work, over 65% of all the missions that went to Mars had failed, had ended in disaster.
It's so difficult that only one country has been successful in landing a rover so far, and that's the United States.
Looking forward, this NASA mission is the first of 3, part of a plan called Mars Sample Return that will ultimately retrieve rock samples Perseverance gathered from Jezero Crater and bring them back to Earth, hopefully as definitive proof of extraterrestrial life.
If we find evidence of life on Mars, then we're going to realize that we're a bigger part of the life story. It's not just an Earth story, it's a universe story.
I hope that happens. That would be a super exciting thing to see.
There's a lot of things that have to happen in order to pull this off. Whether or not we can do it, absolutely yes. Is it easy? Absolutely not. Will it happen? I don't know. I hope so.
And once we prove that, new questions arise. Not are we alone, but now, what or who is out there? That is a question I've been asking since I was a kid, for sure. Now, if it lands safely, we should start getting those first images sometime perhaps during this broadcast or later tonight. But no doubt about it, this is made for television, guys, because this has 23 cameras on board. 7 of those cameras will be dedicated exclusively to those 7 minutes of terror, and it'll be in color. Guys, back to you.
Fascinating stuff, Gio. Thank you so much. You're right there on the ground for us. We'll check back with you in a little bit as everything develops. The moment is almost here.
I know, it's getting so close. Let's dig in now with Dr. Katie Coleman and Dr. Hakeem Olasheyi on the significance of this mission and what's going to be happening today. Hakeem, I want to start with you.
Yes.
What excites you most about this remarkable 2020 Mars mission?
Well, every mission has the same thing: hope and possibility. And for this one, the stakes are really high because this may be the beginning of the mission that actually finds life on another world. So that's one of the things that Perseverance is going to be doing, is looking for signs of or evidence of life, fossilized perhaps. And if that is found, that's going to change everything. So that's incredibly exciting.
Game changer.
Game changer, right? World changer.
Love that. Dr. Katie Coleman, can you explain the value to us of people around the world at home being able to watch and experience this as it happens in real time?
Well, first I'm going to say that I'm listening, and we're a minute away from separating from this. Basically, it's home for the last 7 months.
That's a big moment.
And now we're about to separate the lander and start in about 40 seconds.
Okay.
Everything's looking good.
So it's happening. It's happening
as we speak.
As we speak. Why is that so important?
It did happen, right, on Mars, but we are hearing the signal. So we're following, if that makes sense.
I see.
So it happened 11 minutes ago, but we are following along now, if that makes sense. We still have to follow, make sure we understand all the steps. And what I love about this is that there's a huge team at JPL doing this, and then they're bringing all of us to Mars.
It's very exciting.
Hakeem, you heard Gio mention it, so many of us. We have this fascination with Mars, with Martians, life on Mars. Yeah. What is it that keeps us coming back to Mars for more?
You know what? As a science space nerd, our perspectives are a little bit different. And what I would say is because Mars is the only other planet that has a surface and a sky. And so when I say a sky, if you look at terrestrial bodies, right, there's many with a surface but no atmosphere, bodies like the moon. So you can't go there. But then there are ones that have a surface and an atmosphere but no sky. And I'd say those are Venus and Titan because the atmospheres are so thick you can't even see out of it. But on Mars, right, it's basically the least deadly place in the solar system after Earth.
The most close to Earth.
Well, no, Venus is closer.
But I mean, close to the atmosphere-wise.
Yeah, exactly. We can survive on Mars for some time. And temperatures even get Earth-like at times on Mars. So it's the best place to go. Of all the places in the solar system, Mars is the best place for us to go.
So fascinating. And Katie and Akeem, stick with us. We're just getting started. We're definitely going to be leaning on you guys for all the analysis today. And as we've said, so much is hinging on Perseverance making a safe landing on Mars in the next 20 minutes. When we come back, we will bring you inside the so-called 7 minutes of terror and explain why there's so much riding on those mission-making or mission-breaking minutes.
We'll be right back with Mission to Mars Live. ABC News Live presents Mission to Mars Live. Brought to you by Adobe Sign. Business moves with Adobe.
We are back with former NASA astronaut Dr. Katie Coleman and astrophysicist Dr. Hakeem Olashehi as we await the historic landing of NASA's Perseverance rover on Mars. We have a video here for our viewers to really explain what is supposed to happen during those so-called 7 minutes of terror.
And they start.
Mars is a graveyard of spacecraft.
While the scientists see a magnificent sight seeking the signs of past life, I see danger.
One flaw in the entire process, and that could be the end of the mission.
Failure is a real possibility.
We call it the 7 minutes of terror because it takes approximately 7 minutes for the spacecraft to make it from the top of the Martian atmosphere to safely wheels on the ground. But it's terrifying because the spacecraft has to manage that descent stage all by itself. We come screaming into the Mars atmosphere at around 5.5 kilometers per second. That's around 12 to 13,000 miles per hour.
And that's fast. It's so fast that we could burn up in the atmosphere if we didn't have our aeroshell, our heat shield.
If for some reason our thermal protection system fails, things on the inside will overheat and the structure will overheat, which could lead to a bad day.
That process of entry slows us all the way down to about 500 miles an hour. But that's still not slow enough to land on the surface of Mars. So we have to open up a parachute.
We're deploying the largest supersonic planetary parachute ever used.
We're going almost twice the speed of sound when we deploy that parachute. So it's a very violent opening.
It gives us a neck-snapping 10 plus G's of deceleration.
Perseverance is the first mission to land with its eyes open. Perseverance will have a new technology called terrain relative navigation, which will actually let it see where it is as it's descending on the parachute.
It's still going too fast to land under this giant 70-foot parachute.
So Perseverance will jettison the parachute and then come down on a set of rockets.
About 65 feet above the surface of Mars, we do the sky crane maneuver. We actually lower the rover below its jet backpack and then place it gently on the surface.
Sky crane has only been used once. I don't like the odds of only having done things once. We are always careful to make sure that we don't assume that just because it worked once that it will work again. It'll certainly be a tremendous relief for my team and me personally when we touch down safely. We know that everyone's depending on us.
So exciting. Let's bring in right now Dr. Scott Hubbard from Stanford University, the former director of NASA's Ames Research Center and NASA's very first Mars program director. He's also the author of an award-winning book, Exploring Mars: Chronicles from a Decade of Discovery. Scott, thank you so much for joining us. You've been in this position as a NASA mission director. Help us understand how everyone at JPL is feeling right now as Perseverance is about to enter this 7 minutes of terror.
Well, it's an amazing mixture of anticipation and anxiety. So it's been 8 years of design and development and testing, a lot of testing. And thousands of people have worked on this. You've spent $2 billion of the taxpayers' money. And at this point, the software has taken over. And so you become basically an observer, waiting for those signals, waiting to hear what's happening. But at this point, you can't control anything. So that creates a real dynamic tension inside your emotions.
Scott, thank you so much. You're going to stick around for us. We're going to make sense of this whole thing. And everyone, keep watching. We are just minutes away. When we come back after this break, the clock will start on the 7 minutes of terror. We will be back live at the Jet Propulsion Laboratory to witness it all on the ground. Stick around.
We'll be right back with Mission to Mars Live. ABC News Live presents Mission to Mars Live. Brought to you by Adobe Sign. Business moves with Adobe.
Welcome back to our live coverage as Perseverance approaches Mars's atmosphere. This is the nail-biting moment so many of those scientists at the Jet Propulsion Laboratory have been waiting for.
And we're listening into all of it. Gio Benitez is there on the ground. Dr. Katie Coleman is here in studio listening to what's happening at JPL. And we also have Dr. Hakeem Oluseyi. Hakeem, what exactly stands out to you during these 7 minutes of terror, as they are so hauntingly called, that we're just minutes away from starting right now?
Well, you know, I haven't been in space myself like Katie has, but I have sent instruments into space. And one thing I can tell you is that these people who've dedicated their lives to this mission for the last decade have probably been going through 7 days of terror, right? This is so big for them. They've poured their hearts and their tears into this mission, and $2.7 billion of the people's money. And, you know, everything's on the line right now. And so this is where you just have to have hope and know that the processes that you put in place are going to come through in the end.
Scott, we are less than 1 minute to entry. I want to ask you, they're all hoping this mission goes as planned. How confident are you that we're going to see a successful landing today?
I'm cautiously confident. There's been a ton of testing. The people that are there, I know a number of them, John McNamee and Adam Stelzner, and the people that you've seen on the screen, they're absolutely the best of the best. And so I feel like this will be successful, but you don't know until it gets there. And so we're all just going to be sitting on pins and needles until we hear.
Katie, we are now seconds away, and Perseverance is autonomous. What's happening? What are you hearing? What's going on? So
I'm hearing, distances. They were 190 kilometers, and then just seconds later, 150 kilometers. It's being pulled into the planet. Peak heating is, we're about to have the most heating we're going to have.
Interface.
And
is currently
officially entry interface.
5.3 kilometers per second.
5.3 kilometers per second.
Let's take a listen to what they're talking about at JPL. Why are they quiet?
The fish is now waiting until it begins feeling the atmosphere of Mars to slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target.
Doppler indicates entry into the atmosphere.
Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
Wow. We are probably seeing MRO plasma blackout at this point.
Meaning they're not getting data for a bit because it's going through that part of the atmosphere.
And Hakeem, I heard you say wow. What made you say wow?
Well, when you're moving this fast, 67 kilometers isn't very far.
MRO has lost log.
Are things going well right now?
So far, so good.
We're about indications that Perseverance is now performing bank reversals.
Bank reversals. So it's flying itself home to its place, to its landing spot.
Humans are totally out of control.
That's correct. Well, they were really in control before it left, and that things are so designed and set, but now it's up to everything they've programmed in. It's 2 minutes away from parachute deployment. They'll be going twice the speed of sound.
And what happens during that parachute deployment, Hakeem?
Well, when you think about this spacecraft entering the atmosphere, suddenly it's going from being in the space between the planets, where it's cold and it's feeling nothing, to now it's feeling something, and there's a sudden slowdown. And there's a pressure on the front, and there's not much pressure on the end. And so that friction starts to heat up the heat shield, and that protects it for a while, and it also slows it down. And then eventually, when it gets slow enough, you can deploy the parachute.
And then we're actually showing a graphic for our viewers right now of what that process looks like.
Perseverance is going about 1 kilometers per second at an altitude of about.
Do we have Gio Benitez on the ground there? Gio, if you're with us, what's the mood like where you are in the middle of it all?
Listen, if anybody is feeling the way I'm feeling, I'm nervous. But right now we got an update here from NASA saying feeling the heat and the G's, and they're saying now that it is past peak heating and deceleration. So what that means is, as it was entering the atmosphere, it was feeling heat of 2,300 degrees. Very, very hot. That's why this was just so dangerous. It appears to be past that right now.
Well, and let's bring in Scott again. Katie was mentioning that it's basically driving itself now, the point that it's at. We're seeing it making maneuvers. What does that tell you about what this process is doing and how it's going?
Well, it's adjusting to be able to land very, very precisely. And we'll hear more about that in something called terrain relative navigation. That's driven by artificial intelligence. That'll occur near the end of the 7 minutes of terror. The next big item is the parachute. When you see that decrease in velocity and the parachute's deployed, you can start to sigh a little bit of relief.
Katie, how would you describe what you're hearing, the mood inside Mission Control, and the way things are going?
They are excited, but they are just focused on every event. Parachute deployed.
Deceleration.
That's a big thing.
Deceleration.
Our current velocity is 450.
Describe deceleration to us, because it goes so fast to zero.
So it really just almost stops in place, but not really. So it's going 12,000 miles an hour, something like that. And when that parachute comes out, now it's going slower and slower. But more important, we're going to lose the heat shield. Just lost the heat shield,
which is good.
That means that Perseverance can look down at the surface this and actually do kind of like a where am I, where am I? It has a map in its brain, and then it also has, it's got cameras for eyes, and it's going, oh, I should be over there. So it's actually figuring out where to land. That's why we could land in this kind of dangerous place, is because we have this terrain navigation.
When you say that it's going 12,000 miles per hour, that's so fast, and it's a parachute. I mean, that has to be a really strong parachute.
Well, it's at entry it's 12,000. To deploy the parachute, you have to be below about 1,000, right? So you go to about a factor of 10, and then another factor of 10.
Wow.
Yeah.
A lot of math, a lot of numbers going into making sure it's exactly right.
Yeah. Gio, what are you seeing where you are?
Well, you know what? We're seeing right now on the screen, we're seeing the folks in Mission Control. They are clapping. They are clearly excited about this. But I want to tell you, this parachute in particular, this is also quite historic because this is the first time you have a parachute on another planet like this, a parachute especially this big. And it can't do a whole lot of slowing down because the atmosphere in Mars is just so thin. It is about 1% of what the atmosphere here on Earth is. So it really doesn't slow a whole lot, so they're going to rely on some jets to help slow it down after this parachute.
And we heard Scott mention, right, that, and let's bring Scott back in, that once the parachute deploys.
So we're getting close. So
Back shell set.
Back shell separation. That means that it's flying on its retro rockets and using them to actually just get exactly to the landing site. We're about to do the sky crane maneuver.
Which is what?
Which is where it's on these jet plats. It's actually going to release it about 60 feet off the ground, release it using a crane, and land it.
That sounds like a science fiction movie, but this is really happening.
Only been done once.
Only been done once. This is the second time this maneuver's ever been done, and it's happening right now or minutes ago.
300 meters off the surface right now.
That's nothing.
Yeah, it's very, very close. Scott, do you think that they are feeling good at this point? Like this is actually all going to go as planned
so far?
Yes, I lived through the landing of Curiosity, which is very similar. And you can start to feel the tension release when the parachute goes out, and then when you know that you're at the sky crane level, you're feeling much better, but you need that touchdown, that gentle touchdown.
Tango Delta.
I just heard 20 meters. We've got to be getting very close.
Nominal.
Sky crane.
Wow.
Right now.
We're getting signals from MRO. Bring me stable.
This is the moment.
UHF is good.
Yep.
Touchdown confirmed. Perseverance.
Touchdown confirmed.
On the surface of Mars, ready to begin seeking the sands of past life.
And we see them all celebrating.
How happy you are. Explain. There's a lot of emotion you're experiencing right here next to me. What are you feeling?
Hundreds and hundreds of people have spent the last 8 years making this happen. Look at this.
What are they going through right now?
They knew they could make this happen, and yet when it really does, there's just nothing like it. I mean, this could have been a different day. It's a hard thing to go to Mars. Less than half the missions are successful. And so to make this happen today, it's astonishing. And yet we did know how to do it.
And I want to bring in Scott because, Scott, you know several of the people who worked on this mission. You know this Mars group quite well. This moment right now and this year, it's been such a difficult year in general for the country and for this team. Can you talk to us about what they have been through to get to this moment?
It's been an incredible effort. Kudos to all of them. One of my grad students, when he graduated, went down, and he's been sending me information about the skeleton team that they've been working with, how they've had to do all of this remote working that has never been done before, not with something this complex. So at this point, I know everybody wants to hug everybody else, but they also have to mind social distancing. I can't imagine these conflicting emotions all at the same time.
Hey, Gio Benitez, you are at JPL where this all came from. What is going on there? We just landed on Mars, and you're at JPL. Take it away.
I think all of us were just, We were just so excited when we heard touchdown, touchdown. I'm struck by the name, Perseverance, right? Because the scientists I spoke to here who were involved in this project and making this happen, they were all drawing attention to that. And they said, remember that name, Perseverance, because this launched in July 2020. This launched in the midst of the COVID-19 pandemic. Perseverance, such a fitting name. And the scientists here, that's not lost on them. That's why it's such an important mission for them to give people hope. And there we see them again, clapping and just having such a good time. Because this mission was 8 years in the making. They have been working just so hard to make this happen.
And Katie, you're saying the first images are coming in?
I think that's the first image. That's what they're cheering about.
And what would they be seeing?
Mars.
Thank you for that. I've personally never seen Mars. I feel like I was.
Isn't it amazing? Something
that line is delayed because we're seeing this all.
Well, and I heard you, Hakeem, kind of make a sound when Gio was talking about the name Perseverance, what this group has gone through to get here today, to see those first pictures of Mars today. What caused that reaction from you?
You know, I was thinking all the way back to the beginning of NASA and everything that has gone on and all the people that have sacrificed for space exploration. And here we are now putting our 5th rover on Mars and our first helicopter. It is truly historic, but one day this day will be history, right? And we will be even farther along.
Scott Hubbard, we've landed on Mars. Perseverance has touched down and it's sending back images. What's next? Why is this so monumental?
They're actually...
Well, because it's the beginning of 2 major things. I mean, this is a twofer mission. On the one hand, it's going to carry instruments around that have never been to the surface of Mars before that'll look for the fingerprints of life. And then it begins the Mars Sample Return Campaign. And those of us who've been in the Mars community have wanted to do this for 50 years. So this is huge. I can't emphasize enough the scientific importance of what's going to happen over the next 2 years.
And Katie, I just want to ask you, kind of, what are we seeing there on the screen?
So it was hard to tell, but I think what this is an image from one of the spacecraft that are orbiting Mars, from either MAVEN or the Mars or MRO, Mars Reconnaissance Orbiter. And so it took a picture of Perseverance on the surface, is what I think. But I'm still waiting to get confirmation.
And then Perseverance, in the immediate future, will start trying to take images and send them back.
It has to wake up in the right way. It's a pretty time-consuming process, so it can't take its own pictures yet. But one of the people said, "Hey, I'm going to show you our landing zone."
It's all very exciting. Just a reminder, Perseverance has landed, touchdown on Mars. This mission that started back in July, making a monumental step here, and we have so much more coming up in our special coverage. We're expecting to get more pictures from the surface of Mars any minute now, and we'll bring them to you as soon as they arrive. And as we've mentioned, there's a roughly 12-minute delay in getting images and signals back to Earth. Long way to go.
Yeah, it's far. Also coming up, is there a future for humans on Mars? Not just as explorers, but could we one day live there? The answer may surprise you when we return.
We'll be right back with Mission to Mars Live.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away.
I want to bring in my Good Morning America colleague, Ginger Z. So many people know her as a meteorologist, but she's also a scientist and a fellow space enthusiast. And today, she's been reporting on the bad weather here on Earth. But Ginger, I take it this is actually nothing compared to the weather on Mars.
You know, it's not. I mean, we cannot compare the atmospheres really, but I have to just take a moment and react because as a scientist, this reminds me of, to my inner core, the joy that those folks were feeling in Mission Control is the same joy I often feel when I see a forecast verify and when I'm watching, say, a tornado that I have forecast come to fruition, especially, of course, when it's not impacting people. There is something about understanding our planet here. Imagine understanding another planet well enough that we can land there and learn about it. I can't fathom how they're feeling because I was getting nervous. Seriously, it's right in there. It comes out, and it's just so exciting to see because it gives, in a world where we don't have a lot of control right now, it gives a lot more control, and it gives science a lot to sit on. So anyway, I just wanted to share that because I can feel it in me still. But you know that just this past weekend and throughout this whole week, North Dakota had temperatures drop to 51 below for one of the towns there. That was an all-time record. We know that we've dropped to 144 somewhere on Earth before. But on Mars, their average temperature is 80 below zero.
So what does the perfect summer day look like on a cold desert planet? The answer might surprise you.
During the hottest parts of the Martian day near the equator, on the warmest days of the Martian year, it gets up to about 70, 80 degrees Fahrenheit on some days.
Even if you could feel that balmy breeze through your spacesuit, which would be keeping you alive in a place with almost no oxygen, don't get too comfortable. And those warm summer days on Mars, well, they don't last long. They have an atmosphere that's 100 times thinner than we do here on Earth, so it can't hold the heat.
Mars dips down to temperatures well below zero, many tens of degrees below zero at night. So not a very clement place, not a very nice place to be for very long in terms of temperature.
And you know what? It's that thin atmosphere on Mars that makes the weather that we think we know here on Earth behave a whole lot differently out there.
The vast majority of water on Mars today is frozen in ice. There's a very small amount that's in the vapor in the atmosphere, and it also can condense into clouds in the atmosphere.
But the amount of water vapor is so small, even in what you might consider their wet season.
If you condensed it all out onto the surface, it would only be a layer that's maybe something like 60 microns thick. So that's like maybe 3 times the width of my hair.
Something that does thrive in a cold desert? Dust, especially when there's no water to stop it.
On Earth, those little particles eventually bounce their way into a body of water, like a lake or an ocean, and then they get trapped and they settle out. Because Mars doesn't have any of those bodies of water today to trap the dust, it just stays there in the climate system, gets broken apart as it's whipped around by the winds.
Ready! But that windstorm that stranded Mark Watney at the beginning of The Martian probably couldn't happen.
Even a strong wind on Mars to a human, it's not going to blow you over because the atmosphere is so much thinner. It doesn't have the molecules pressing against you with that wind that would actually be that big of an impact. It's not going to create the same force.
Mars wasn't always a cold desert.
Mars was once like Earth in that it had lakes, it had rivers, it had hydrothermal systems like Yellowstone bubbling off. And one of the most important questions in Mars exploration is what happened. The more you explore, the more you realize how precious our planet is that has managed for over 4 billion years to keep habitats that are good for life. There's no place like it in the solar system. Mars was once the closest, but there's really no place like Earth. So it really puts it in perspective as we study the climates of other worlds, how important climate is on our own world for us.
Now, if you turn this around and you did this for Earth for the first time, you wouldn't just study one place on Earth and then say, yep, we know everything about the weather across that entire planet. Well, the same is true for Mars. You have to realize that there are other different parts of Mars that we have been studying. So we're kind of creating a network of weather observation sites. And that is going to help scientists study the data from META, that new one that's going on there now, the weather station that they'll have with Perseverance rover, along with the other data from other weather stations. So it kind of comes together. That is going to help them get a better understanding of how things like storm systems might change as they move across the red planet. So a lot to be learned. And I can't imagine, again, I keep thinking about turning around on Earth. And for a long time, we only have one picture, and we don't know. And think about from rainforest to Antarctica to the Sahara Desert. Think about how many different microclimates we have and how much we're about to discover about Mars.
So much to learn. Ginger, I'm also curious if you can give us an idea of the climate on Mars. Is there anything we can compare it to in our Earthling brains?
Eva, I heard Will saying earlier, well, I was in 40 below. Isn't that like Mars? Yeah, I'm sure temperature-wise, because he was throwing boiling water earlier this week into the air and doing the age-old experiment here. But that's the difference. You really can't compare because of that water vapor. I don't think you can say, oh, this is just like it. But if I had to, if I was forced to not scientifically place a place on Earth to be like Mars, it would be like moving the Sahara Desert to Antarctica, perhaps, without any of the moisture. It's very hard to do that.
There's no place quite like it.
I just want to correct the record. I was wondering the difference between 40 below and 80 below on Mars. Can you tell the difference? That's all.
You didn't think, oh, I've been on Mars?
I don't know.
I've been on Mars. I was in Nebraska.
I asked Dr. Coleman what Perseverance is taking pictures of. She said Mars. So I'm getting it from all sides here, but whatever.
Cold is cold.
Yeah,
that we know.
That's right.
Taking those pictures.
Yeah, right, of course.
ABC News Chief Meteorologist Ginger Zee, thank you so much.
All right, thank you, Ginger. And Eva, it is 2021, and what do you do at the end of a long trip when you arrive at your destination? You tweet. And that is what Perseverance has done, tweeting out, "Hello world, my first look at my forever home." Dr. Katie Coleman, what will the rover they call Percy be doing in her new digs?
In Mars. In Mars.
What's she going to get up to? How's she going to spruce up the place?
Well, she's got a lot of exciting instruments on board to be able to really understand where she is, which is basically in the middle of a big lake where a river dumped in there, and then all this sediment went in there. And so we're going to be able to look at, in that sediment, was there any microbial life trapped in there? So we've got all these instruments, and they're really fun. It's almost like laser tag on Mars, where one of them you can actually use a laser the size of a human hair and shoot at a rock, explode the rock, look at the image and understand what elements are present. So that's just one of the ways. We've got cameras on board. The mast cam, which stands up really tall, has for the very first time on Mars zoomable cameras. We've always just had like a wide angle and then a zoom, and now that we have ones that can zoom together, we can actually make stereo vision on Mars. It's good for the rover for when it's using its robotic arm, wants to know, and it's also great for us to understand the terrain and actually get to go on a trip there, I think, and really feel like we're there.
I want to know more about these cameras. Let's go to Gio Benitez, who's at JPL. What do we know about the cameras that are on this rover?
Well, you know what, Eva? First off, I want to go ahead and tell you that I'm over at the Wally cam. I'm calling it the Wally cam because it kind of looks a little like Wally, right? So I just want to show you, because there's a very specific reason why this image was so low res, the one that we've been seeing there. Because if you take a look right here, we're going to have this camera zoom in here so you can see this is where that image is. It's coming from these cameras. There's another camera in the back, and these are called the HAZ cams. These are the hazard cameras. The very specific purpose is to make sure that this landed safely and that they could see whatever it is that they could see right there at that particular spot very, very quickly. And that's why it's a low-res image. So it's very, very important to get that so quickly. But now, over the next few hours and days, we will start getting more images in color from the other cameras. Again, 23 cameras on board the rover right now.
So we're going to see better pictures. Well, continuing coverage of the mission to Mars when we return. Stay with us.
We'll be right back with Mission to Mars Live. ABC News Live presents Mission to Mars Live. Brought to you by Adobe Sign. Business moves with Adobe.
And welcome back to our continuing coverage of the Mission to Mars. We've got the first picture. She's already sent out the first picture on a tweet.
She's on it.
She's
Perseverance, which they call Percy for short. Look at that. That's Mars. Right, Dr. Katie Coleman?
It's true. I thought it was from above, but.
So there we go. So what are we seeing? Hakeem, we'll start with you.
Mars ground. We're seeing the ground in Mars, and we're also seeing that Perseverance is safe, which is most important.
That is good, because that means that we can continue the mission, because what started in July, taking off from Earth, has finally arrived on the red planet, and now the real fun begins, no?
Exploring. And actually, this is a place that generations of Mars explorers have waited to get to. We've had to learn our lessons. I mean, land in really safe places, getting better and better at landing. And now we were good enough to land in this really interesting place where it's literally this river delta with all these sediments that we want to explore. And yet it was dangerous because we needed the terrain relative navigation to be able to make sure we didn't hit anything and landed in a good place. So we're in a place, we're ready to explore. It's going to take some time and patience to wake up the rover and test out all the instruments and all those kinds of things. But one of the things it's going to do is actually drill down, take samples in different places on Mars, store them, and then those samples will be making a return trip back to Earth so we can analyze them here.
Very cool. And I want to bring in Dr. Scott Hubbard. I mean, this is just the beginning of the actual mission part where it has all these tools on board this rover. Talk to me about what you're most excited about to see the rover working on this mission.
I'd say there's two different pieces. One piece is the instruments that Katie was talking about, the ones that are going to probe the undersurface. There's a ground penetrating radar. There's an instrument that's going to take some of this thin atmosphere and try to make oxygen so that future astronauts, when they get there, will have a way of supplying their needs as well. But the most exciting piece for me personally is that arm that's got the drill on the end of it that's going to take those samples and deposit them in these special tubes for return. We hope about 10 years from now, 2031, we're hoping those samples will be back on the surface of the Earth.
Quickly, Gio Benitez, you are on the ground at JPL. What are you seeing there? What's the latest?
You know what? A lot of people here are obviously very, very excited about this because this is something where they have been working for so long on this particular mission. And I think we have another camera here because I want to go ahead and just walk over here to show you because this is just the beginning, right? You have perseverance, but you also have ingenuity. And right here, this here is that helicopter. This is going to be the first ever helicopter to fly on another planet. It is just 4 pounds. This is going to be taking some drone-like images, okay? That will be historic because it is the first time you will see the most epic drone-like pictures that we've ever seen, and it's going to be coming from this. And it's going to be living on Mars also, forever. It's got that solar panel right there, and hopefully it survives that in about 2 months. That's when they're going to go ahead and release it, and that's when they're going to try to fly it. So it's very exciting. This is just the beginning of some major, major science projects on Mars that could really change the way we see the universe.
Ingenuity, the name of the helicopter. Whoever names stuff at NASA deserves all the credit in the world because
very clever.
It really is ingenious. But we'll stay with us because when we return, I will make more silly jokes and we'll go back to the Jet Propulsion Laboratory. We'll find out what's next for the Perseverance rover on Mars, where it has landed safely. Stick around.
We'll be right back with Mission to Mars Live. ABC News Live presents Mission to Mars Live. Brought to you by Adobe Sign. Business moves with Adobe.
And and lots of celebrations. Perseverance has safely and successfully landed on Mars. We want to bring in our experts. Hakeem, your final thoughts on this historic afternoon?
Well, we treat each one of these like it's a big deal because it is, but also it's just the beginning of the next stage. And what makes this mission so amazing is that we've built up all these levels of exploration to now we can finally say on this mission, we're looking for signs of life. And that just blows me away, that we could go to another world that we've already scoped out to find the best places and now go and attempt to do this. This is truly just blows my mind that humanity can do this.
So Katie, cool. You, among many other people, were emotional when Perseverance touched down. Try to contextualize this. What does this all mean for exploration?
Like Hakeem was referring to, I mean, this is something that has been done once. You know, that whole 7 minutes of terror, it's been done once and it worked. But to have it happen the second time, I mean, first of all, it's superior engineering, it's team dedication, but there still has, I mean, Mars is hard. That's why we don't go often. That's why there's nothing, you know, it's really amazing. And more we're bringing everybody there. I mean, we've just had 3 spacecraft in the orbit of Mars, you know, new ones in the past month, right? I mean, because there's Perseverance, Mars 2020, there's the United Arab Emirates, and there's China. So it's really becoming, you know, everybody is getting there. I like to say this is not your grandmother's rover. And that's what's really a big deal about this. And it's not your mom's rover, but it is your rover. Because so many of the experiments they're doing, the samples they're bringing home, our kids are going to be the ones that analyze those.
And at JPL, where Gio Benitez is right now, they have on the wall there, dare mighty things. Today, they accomplished something pretty mighty, Gio.
This is extraordinary human achievement at its best. And I want to go ahead and tell you that over the next few hours, NASA is telling us that we will start receiving higher resolution images, that they will start coming in, perhaps even some sounds. So tonight at 10 p.m. Eastern, right here on ABC News Live, we are going to have more on this mission to Mars coverage, this historic mission to Mars coverage. So join us for that as we see much more from Percy here.
Gia, thanks so much, and our thanks to Katie, Hakeem, Scott Hubbard, and thank you at home for coming along with us for this historic and successful ride. I am Will Reeve. We'll continue to bring the latest images and news out of this historic mission to Mars, and at 5:30 Eastern, we'll bring you a live press conference from NASA on today's incredible mission.
And I'm Eva Pilgrim. Thank you for joining us. We'll be back tonight right here at ABC News Live at 10 p.m. Eastern for a primetime special, complete with those latest pictures and sounds coming in from the Red Planet that we will share with you then. From everyone here at our own ABC News Live Mission Control, we hope you'll join us again tonight.
And I can't see straight, hate it, but it's just what we take. I've been bitten by the lonely, but when I'm not the only, when I'm not the only one who feels it, maybe it's sick to say, but it helps that you feel the same.
With so much at stake, so much on the line.